Hello everyone. In the previous lecture, I covered the concept of lambda functions using simple dictionary sorting examples. In today's lecture, we'll be writing transformation functions in the form of lambdas. We'll be applying the lambda transformation function using the map function to transform a list of items. Let's go through example 1, which is asking us to use map and lambda to make a new list of integers from numbers in such a way that we square each of the items within the numbers list. Recall that the map function takes two arguments. The first argument is going to be the function object reference to the transformation function. Clearly, we'll have to write our lambda function here. The second argument is going to be the list object instance reference, which is going to be the variable numbers in this particular example. Recall that lambda functions deal with a single item as part of the original list of items. So we are going to consider one integer object instance and square that particular integer object instance within our lambda function here. The syntax for lambda function is to type the keyword lambda followed by which you'll have comma separated parameters. Since we are dealing with one integer object instance, we are only going to have one parameter. Let me use the variable name as x for that parameter. Following the comma separated parameters, we are going to type in a colon, and then finally you'll type in the single line of expression, which is going to be the body of the lambda function. What should be the expression for this particular lambda function? We simply want to square x, so I'm going to type my expression as x double asterisk 2 here. What are we doing with the return value of the map function call, which is a generator object instance? We are simply converting that into list data type using the list function call. When I execute this cell, we are now going to produce a brand new list object instance, which is storing the items as the squared values of the original items in the numbers list. Please feel free to go through the rest of the lambda plus map examples on your own if you want practice for exam 2. In the rest of this video, I'll be covering the examples through s underscore prime example here. Let's go through example 2, which is asking us to make a new list of floating point values from vac underscore rates in such a way that we round down each of the floating point items to 3 decimal points. Let me type in list open parenthesis close parenthesis. Within that, I'm going to type in map open parenthesis close parenthesis. The second argument for the map function call is going to be vac underscore rates. Let's write down our lambda function, which is going to be the first argument. I'm going to type the keyword lambda. We are going to have one parameter for this particular lambda function as well, because we have to deal with one floating point object instance from the original list, which is being referenced by the variable vac underscore rates here. Let me use the parameter variable name as x. Then I'm going to type in a colon. What should our single line of expression here be? That's going to be a call to the round function. Recall that the round function takes two arguments. The first argument is going to be the variable which is storing the reference to the floating point object instance. That's going to be our parameter x here within the lambda function. The second argument should be 3 to indicate that we want to round down to 3 decimal points. Once I execute this cell, we are going to produce a brand new list object instance where the items are rounded down to 3 decimal points. Let's move on to the next example, which is asking us to make a new list of integers from words. Observe that words is a list which contains strings as items. How should we generate the integers? Each of the integers should represent the length of the corresponding string from the original words list. So I'm going to type in list open parenthesis close parenthesis. Within that, let me type in map open parenthesis close parenthesis. The second argument is going to be words. Let's write down our lambda function as part of the first argument. Since we are dealing with string object instances, I'm going to use the parameter variable name as s here. So I'm going to type in lambda space s, then a colon. What should our single line of expression here be? We want to compute the length of each string. Recall that you can call the len function and pass s as argument. That is going to enable us to generate a brand new list object instance which contains integer items. Each of those integers are going to represent the length of the corresponding string item from the original words list here. Let's move on to the next example, which is asking us to use sorted and lambda function to sort this list of dictionaries based on the score value from low to high. Recall that we covered a similar example as part of the previous lecture where we sorted a list of hurricane dictionaries. We wrote our own custom functions to pass as function object reference to the sorted function. In today's lecture, we'll be writing lambda functions to solve the same problem. Let me type in sorted, and I'm going to type in my first argument as scores within the parenthesis. The second argument is going to be for the parameter key. So I'll have to mention key equal to what should be the argument here. That's going to be our lambda function. So let me start typing the lambda function by typing the keyword lambda. Just like the previous lambda functions, this lambda function is also going to deal with a single item within the original list of items. So this lambda function is going to deal with a single dictionary. So let me use the parameter variable name as d here. Then I'm going to type in the colon. What should be our single line of expression here? That's going to be the lookup for the key score. So I can do that by typing in d of score, and that's going to enable us to indicate to the sorted function that this particular key within the dictionary is significant when it comes to the sorting. The sorted function call automatically takes care of doing the ascending order sort for the scores here. So if I execute this particular sorted function call, we are going to get a brand new list object instance where the dictionaries are sorted based on the ascending order of the scores here. Observe that we are getting Bob first, Cindy next, and Alice last here. The next part of this question is asking us to modify the lambda function part alone in such a way that we are able to sort the list of dictionaries based on the score ordering from high to low. Recall that we covered two different ways of doing descending order sort as part of the previous lecture. One of those ways is to include a transformation as part of the function object reference that we pass as argument to the key parameter, which is indicating to the sorted function or the sort method call as to which particular key within the dictionary is significant for the sorting. I can simply negate the lookup value of d of score here to achieve the descending order sort. Observe that now we are getting a list of dictionaries where the dictionaries are sorted by descending order. We are getting Alice first, Cindy next, and Bob last here. The next part of this question is asking us to go back to the previous version of the lambda function definition. So I'm going to remove the negation here as part of the lambda function's one line lookup. Then I'm going to use the sorted function's parameter of reverse to solve the exact same question. Recall that the reverse parameter takes as argument a boolean value. If we pass a boolean value of true, that's going to enable us to perform the descending order sort of the list of dictionaries here based on the score value. Observe that we are getting the exact same output. Let's move on to the next example, which is asking us to fix this particular s underscore prime function's definition in such a way that it is able to return true if the provided argument is a positive integer and return false if the provided argument is not a positive integer prime. So Just to clarify, I mentioned that it should return true if the provided argument is a positive integer. I meant if the provided argument is a positive integer prime. Sorry about that. Let's go through the function definition. The s underscore prime function is having n as the configured parameter. Then we have a for loop over here. What exactly is this for loop doing? We are using the range built-in function call to iterate over the sequence of numbers from 2 up until n divided by 2 plus 1. So this particular for loop is going to check integer divisors from 2 to n by 2 minus, sorry, plus 1, correct? So why exactly can we stop at n by 2 plus 1? The naive way of solving whether a particular number is prime or not is to check all the divisors from 2 up until n minus 1. You don't really need to check all the divisors from 2 up until n minus 1. That's because when you factor a given number, the factors cannot be larger than n divided by 2 plus 1, correct? That's why we can stop at n divided by 2 plus 1, of course, taking into consideration the integer division using the double division operator here. An even better optimization would be to stop at square root of n. That's because two factors for a given number n cannot be any greater than the square root of n. I'm just going to use the first optimization here. Let's go through the lines of code within this for loop. So we are going to check every divisor from 2 up until n divided by 2 plus 1. Recall that you shouldn't check 1 as a divisor because every number is divisible by 1. So what is our if condition here? We are checking if n mod I equal to 0. This implies that the divisor I is able to cleanly divide the number n because it does not produce any remainder. Clearly then the number n is not a prime. So in order to fix this return statement, we'll have to type in the boolean value of false as part of the return statement here. So what should we do outside our for loop? We need to return true. That's because we have gone through all of the divisors from 2 up until n by 2 plus 1, and none of the divisors are able to cleanly divide the number n here. So clearly n must be a prime number. Let me execute this particular cell. Observe that we are getting true for the argument 2 and true for the argument 13. That's because 2 and 13 are prime numbers. 34 on the other hand is not a prime number, so this is giving us a return value of false. I'll wrap up this lecture video here. In the next video, we are going to learn the concept of iterables and iterators.